Okay, we're going to calculate a couple of derivatives. The derivative of e to the 2x times the cosine of 3x. Here we have a product of two functions, u times v, where u is e to the 2x and v is the cosine of 3x. And so this derivative from the product rule is equal to the derivative of e to the 2x, which for the moment I will just indicate because that's not a simple derivative, and then times the original second function, cosine of 3x, plus the original first function, e to the 2x, times the derivative of the second function. And this derivative is also not a basic function, it's a composition, so I'll do that in the next step. So our u prime and our v prime, they're both compositions and they both require the chain rule. The chain rule says the derivative of f of g of x is equal to f prime of g of x times g prime of x. So in the first case, our g of x is the inside function, that's the 2x. And so this derivative is the derivative of the outer function. The derivative of the exponential function is itself. So we just have e to the 2x. And then times the g prime of x, which is 2. The derivative of this 2x is 2. So we'll put that there, times cosine 3x. And then we have plus e to the 2x times the derivative of the cosine of 3x. This time the 3x is inside of the cosine. So we take the derivative of the outside. The derivative of cosine is negative sine. We leave the 3x in, and then we multiply by the derivative of the inside, which is 3. So we'll just rewrite the answer, moving this minus and this 3 to the front of the second term. So minus 3 times e to the 2x times the sine of 3x. And if we wanted, we could also factor out the exponential and write an exponential times some trig functions, which is in the same spirit as the original function. We had an exponential times a trig function, and the derivative is that same exponential times this trig expression here, 2 cosine 3x minus 3 sine 3x. For our second problem, we also have a composition. The cotangent function is inside of the function 2 to the x, and the derivative of 2 to the x is 2 to the x times the natural log of 2. So in other words, if f of x is 2 to the x, then f prime of x is 2 to the x times the natural log of 2. And I'm using this notation because in the chain rule, we have to consider f prime of g of x. So the expression f prime of g of x, we replace the x in f prime of x with g of x. So we get 2 to the g of x times the natural log of 2. So we take the derivative of the outer function, which is the exponential function with base 2, and we leave the inside function in, so that's the cotangent. So our f prime of g of x part of the chain rule will be 2 to the power cotangent of x times the natural log of 2. 2 to the power cotangent of x times the natural log of 2. That's the derivative of the outer function, the exponential function with base 2, leaving the inside, the cotangent, in. And then we have to multiply by g prime of x. That's the derivative of the inner function. The derivative of cotangent x is negative cosecant squared x. And we could improve this ever so slightly by just putting the minus to the front. So negative 2 to the cotangent of x times the natural log of 2 times the cosecant squared of x.